A sleepy cosmic heavyweight has stirred intense curiosity among astronomers who hunt for clues to the earliest beginnings. They have uncovered evidence that points to a massive black hole that spent ages in a quiet phase when everything around it in the early universe roared with activity. Scientists studying cosmic data have identified a black hole that formed during the universe's infancy and then settled into a subdued state. This strange behavior contrasts with the bright and voracious black holes that swallow matter at relentless speeds. Roberto Maiolino, University of Cambridge, notes that this object hints at many more black holes that could be lying low, even when galaxies all around them shine like city lights at night. This special black hole offers a puzzle that stretches far beyond the typical understanding of growth rates in newborn galaxies. The black hole appears to have gained its heft much earlier than expected. Observers are intrigued by the sheer scale it reached in such a short span, despite its current quiet appearance. It suggests a rapid feeding period at some point, followed by a lull. Researchers were amazed to find traces of activity that once blazed, even though the black hole is now unusually faint. Astronomers believe short outbursts of heavy feeding might explain how it managed to pack on so much mass while staying in the shadows for long stretches. Each surge of matter could have been powerful enough to pump the black hole's size larger, yet brief enough to avoid prolonged bright emissions. The host galaxy seems to have avoided building many stars during the black hole's heyday. Some suggest energy thrown off by the black hole likely heated or pushed away the gas that would have otherwise sparked star-making episodes. Independent experts praise this discovery for challenging their traditional views. According to NASA's Goddard Space Flight Center, early black holes were thought to shine brightly, but this one shows that some might hide in dimness for eons. Other astronomers believe dormant behemoths might be scattered across the ancient cosmos, waiting to be detected. They note that a quiet black hole is tricky to spot because it blends in with its galaxy, and is overshadowed by the many smaller stars around it. Researchers spotted subtle signs in the galaxy spectrum. Faint emission markers hinted at a central black hole that may have formed from either a heavy seed or a rapid stellar collapse. Scientists also measured specific patterns to learn about its environment. That data helped them separate the black hole's contribution from the broader starlight, so they could gauge the object's size and overall power. Evidence points to an underpowered galaxy surrounding this black hole. It appears dimmer than one might expect for something hosting such a colossal mass. Experts hypothesize that blasts of energy linked to earlier black hole growth might have stifled its star-making potential. Gas clouds that feed newborn stars were either heated or expelled, leaving the galaxy with less raw material to shine. This find has fueled healthy scientific debate. Some claim large seeds from pristine gas clouds might explain the mass, while others favor small seeds that went through spurts of very fast growth. Every approach tries to reconcile a huge black hole with an otherwise calm environment. The varied perspectives reflect how unusual this sleepy giant is among the bright lights of ancient galaxies. Space watchers believe this discovery may push scientists to adjust models of early cosmic evolution. Large black holes appearing so soon are tough to place in standard timelines. Detecting more hidden giants would confirm the universe holds many stories that we have barely noticed. Sleepy black holes serve as living fossils from the dawn of time. They embody violent feeding episodes that helped shape galaxies, even if those episodes didn't last long. Their subdued nature suggests there might be countless black holes that enjoyed a wild youth but now remain unassuming. Astronomers hope to map these hidden objects to fill gaps in early cosmic history. The black hole in this study is a single example of what might be an entire population. Surveys probe new regions daily, armed with sharper instruments to reveal faint and distant signals. Researchers believe these black holes are as widespread as they are sneaky. They suspect that a small fraction produce bright flares, while the majority slip beneath detection limits. Learning about such objects helps communities focus on the big cosmic picture. Studies of black hole impacts on galaxies shed light on how stars and planets form, which ultimately relates to the conditions that allow life to emerge. Rethinking early black hole growth patterns may also lead to new technology spin-offs. Advances in data analysis, imaging, and sensor design often trickle into everyday tools and applications. Astronomers plan to revisit these distant targets with more refined equipment and deeper observations. They hope to tease out hidden details that can confirm or refute current models. Some aim to study these black holes at multiple wavelengths to catch any lingering wisps of older, more active states. Every fresh insight strengthens our ability to chart cosmic ancestry back to the earliest epochs. Observations will rely on advanced computational models to forecast where other dormant objects might be hiding. The synergy between telescope data and simulations helps refine predictions and sharpen detection methods. Scientists remind enthusiasts that many of these discoveries hinge on patience and timing. A faint, overshadowed black hole can escape detection for a long while unless it happens to brighten again. The biggest takeaway is that not all black holes shine brightly. Some can gain mass fast and then rest in silence, challenging our imagination. Researchers remain open to the idea that more of these objects exist but are simply overshadowed or masked by dust. Read the full article on Earth.com by clicking on the link in the description.